Hi everyone, this is Dr. Nak and we're going to be learning about how to add, subtract, and multiply radical expressions today. And as you heard at the very beginning of this video, my dogs will be joining as well. Let's first go with the definition of like radicals. So like radicals are the radical expressions with the same index and the same radicand. So for an example, let's take a look at maybe 3 square root of x plus 5 square root of x. For this one, like radicals will be the square root of x. They're both square root, and then the radicand are both x. So in this case, all you have to do is just combine the constants, which will be, I'll work this step by step. Basically what you're doing is 3 plus 5 multiplying here by the square root of x. So here we're gonna have 8 square root of x. Now let's look at something like 3 square root of x plus maybe 5 square root of x to the third. Okay, so do you think we can combine these two? Answer is no, because although we're given both square roots, the radicands are different. So this is not like radicals. So in this case, this expression cannot be simplified. Okay, now let's take a look at something like 3 times square root of x plus 5 times cube root of x. This expression also cannot be simplified because roots are different. First one, you're given the square root, and then the second one, you're given the cube root. So again, this cannot be simplified. Let's do some examples. Example 1, simplify. So let's take a look at 8 square root of x minus 10 square root of x. Do we have like radicals? Yes, we do. The like radical is the square root of x. So all you have to do is pretty much you go 8 minus 10, and then you just attach the radical. So if I have to do this step by step, this will be 8 minus 10, multiplying here by the square root of x. So this is negative 2 square root of x. Now let's take a look at 5 square root of 2 plus 9 square root of 2. Do we have like radicals? Yes, we do. That would be square root of 2. So in this case, we're going to have 5 plus 9 times the square root of 2, which would be 14 square root of 2. Part C, let's take a look at 1/3 square root of 5xy minus 3/5 square root of 5xy. Okay, do we have like radicals? I think we do. That would be square root of 5xy. So we're going to do the same thing. Don't get thrown off because you see some fractions here. So here we're going to go 1/3 minus 3/5 and then multiply here by square root of 5xy. Now we still got work to do. So if I combine what's in the parentheses, the least common denominator will be 15. So that means that I need to multiply this guy by 5 and a 5, 3 and a 3. So what we're going to get is 5 over 15 minus 9 over 15 and the square root of 5xy. So in this case, what do? We just combine the numerators together. And then I'm going to multiply here by square root of 5xy. Again, I'm trying to do this step by step. So 5 minus 9 gives us negative 4 over 15, multiplying here by square root of 5xy. And I'm going to box that for the answer. All right, now let's look at another one. So do we have like radicals here? Yes, we do. That will be square root of 3yz. So we're going to work this step by step again. So I'm going to do the same thing. So let's first combine 1/2 minus 5/2. What would be the next number? Remember, there is that invisible 1 sitting here, so don't forget that. So this is going to be plus 1, and then multiplying here by square root of 3yz. So let's make that all into a common denominator of 2. So here what we're going to get is 1/2 minus 5 over 2 plus 2 over 2, and then square root of 3yz. And what do we get here? So it looks like we're going to have 1 minus 5 plus 2, whole thing dividing by 2, multiplying here by the square root of 3yz. So what do we got? So 1 minus 5 is negative 4. Negative 4 plus 2 is negative 2. So here we're going to have negative 2 over 2 square root of 3yz. Make sure to simplify your answer all the way. So this is just going to become negative square root of 3yz. Let's do more examples. Example 2, simplify. Square root of 20 plus 3 times the square root of 5. Alright, so first of all, do we have any like radicals? Nope, not in this case. So in that situation, what you need to do is you need to simplify square root of 20. So let's do this. So we got 20 and 2 times 10 and then 2 times 5. So 20 is 2 squared times 5. So therefore, let me work this step by step. Square root of 20 is 2 squared times 5. And plus, let's just leave 3 times the square root of 5 alone. And now what's going to happen? We have a perfect square there. So this is going to be 2 times the square root of 5 plus 3 times the square root of 5. Now combine those together and what do we get? We're going to have 2 plus 3 times the square root of 5, which is 5 square root of 5. Too many 5s flying around, but hopefully you were able to follow that one. Now let's do another one. Let's take a look at cube root of 24 minus cube root of 375. Clearly we don't have any like radicals, so we're going to have to simplify. So let's get to work. So let's first break down 24. So 2 times 12, 2 times 6, what is that? 2 times 3. So 24 is 2 to the third times 3. And what the heck? Let's just break down 375 as well. Why not? So first one, 5 goes in there. And this will be 75. Again, 5 is going to go in there. 5 times, what is that? 15. And then 5 times 3. So it looks like 375 is 5 to the third times 3. So I'm going to rewrite both of the radicals as cube root of 2 to the third times 3 and then minus cube root of 5 to the third times 3. Looking good because we got the perfect cube going on. So, what's going to happen now is that this is going to be 2 times the cube root of 3 minus 5 times the cube root of 3. Alright, now I see the like radicals. Like radical is going to be cube root of 3. So here what we're going to do is do the same thing. We're going to have 2 minus 5 times the cube root of 3. So in this case what we're going to get is negative 3 cube root of 3. What the heck? In the previous one it was all 5, now it's all 3's. But alright, so let me go box that for the answer. Alright, now let's take a look at something that involves fractions. So we got 1/2 times 4th root of 48 minus 2/3 times the 4th root of 243. Do not panic just because you see fractions. We got this. So let's take one step at a time and we're going to do the same thing. Let's break down 48. So this is 4 times, what is that, 12, 2 times 6, 2 and a 3. So 48 is 2 to the 4th times 3. Now let's go with the 243. What goes in? Does 3 go in? Yep, 3 goes in. So this is going to be 81. 9 times 9, 3 times 3, and then 3 times 3. So it looks like 243 is 3 to the, what do we got? 1, 2, 3, 4, 5. 3 to the 5th. Alright, so now let's break it down. So this is same thing as 1/2 times the 4th root of 2 to the 4th times 3. And then minus 2/3 times the 4th root of 3 to the 5th. But what we're doing is we're looking for perfect fourth. So I'm going to break down 3 to the 5th into 3 to the 4th times 3. So let me rewrite that as 3 to the 4th times 3. Now I'm going to circle the perfect one. All right, now this is going to be 1/2 times 2 times the fourth root of 3 minus 2/3 times by the 3 of the fourth root of 3. Now 2 is going to cancel, 3 is going to cancel, so it looks like what we're going to get is just 1 times the fourth root of 3, which is just fourth root of 3, and then minus 2 times the fourth root of 3. Now remember, there is that invisible 1 sitting there. So this is same thing as 1 minus 2 times the fourth root of 3, so which gives us negative 1 times the fourth root of 3, or negative fourth root of 3. So this is our answer. Okay, let's take a look at another one. So please pause the video right now and try this problem on your own. Alright, so let's see you got it. So first, I'm going to do the same thing. I'm going to break down 128. So what goes in, it's even, so 2 is always going to go in. So 2 times, what is that, 64, is that right? Yep, and then 64 is 8 times 8. 2 times 4, 2 times 4, and then 2, 2, 2, 2. Alright, so 128 is, how many 2's do we have? 1, 2, 3, 4, 5, 6, 7. Alright, so this is going to be 2 to the 7. Now let's go with 54. So what goes in? 2 is going to go in. So 2 times what gives 54? That would be, what is that, 27? Does that work? Yep. Alright, and then 3 times 9, and then 3 and a 3. So here, 54 can be written as 2 times 3 to the third. Okay, now I'm going to come back over here and let's rewrite 1/2 times the cube root. Okay, so now let's rewrite 128. Now we're looking for is perfect cube. So the break-off point for 2 to the 7th should be 2 to the 6th times 2 to the 1st. Do you see why? Because remember, 3 goes into 6 nicely. Alright, but anyway, so here let me just rewrite this guy as 5/3 times the cube root of 3 to the 3rd times 2. So this one was cool because you're already given the perfect cube. So I'm going to circle the perfect ones. So here what we're going to get is 1/2. Now remember, let me just work this on the side. Remember when we had a cube root of 2 to the 6th, that's same thing as 2 to the 6 over 3, which will give us 2 to the 2nd, which gives us 4. Alright, so here what we're going to get is multiplying here by 4 times the cube root of 2, and then minus 5/3, and then we have a cube root of 3 to the 3rd, so that's just going to be 3, and then cube root of 2. Alright, now 2 goes into 2 once, into 4 twice, so it looks like what we're going to get is 2 cube root of 2, and then here 3 is going to cancel, so we have minus 5 times the cube root of 2. Alright, one more step, combine this, so we have 2 minus 5 times the cube root of 2, so this is negative 3 times the cube root of 2. So how did you do on this one? If you didn't get it right, make sure to catch your mistakes. That's the most important part. Alright, what the heck, let's just take a look at another one. So again, pause the video and try this on your own to see if you can do it or not. Alright, so hopefully you got this, so let's go over it. So again, we're going to do the same thing. I'm going to break down 80, and this is 8 times 10, 2, 4, 2, 2, and then 2 times 5. So 80 is 2 to the, how many 2's? 1, 2, 3, 4, 2 to the 4th times 5. Now let's look at 405. 5 is going to go in, and you're going to have 5 times 81, and then 9 times 9, 3, 3, and then 3, 3. Alright, so it looks like 405 can be written as 3 to the 4th times by 5. Okay, so looking good because what we're looking for is that perfect fourth. So let's rewrite. So this is 5 over 2 times the fourth root of 2 to the 4th times 5, and plus 7 over 3 times the fourth root of 3 to the 4th times 5. All right, I'm gonna circle the perfect ones. Then what do we get? 5 over 2 times fourth root of 2 to the 4th is gonna be 2. And then here what's left is fourth root of 5 plus 7/3. Now again, fourth root of 3 to the 4th is just gonna give us 3. And then what's left is fourth root of 5. All right, so now I think it's looking good. 2 can cancel, 3 can cancel. So this is going to be 5 times the fourth root of 5, and then plus 7 times the fourth root of 5. So this is 5 plus 7 times the fourth root of 5. So this will be 12, fourth root of 5. All right, so how did you do on this problem? Hopefully you are kind of getting used to it, because what we're going to do now is we're going to learn how to multiply the radicals now. Okay, so first let's recall these properties. Nth root of a times b. This is nth root of a times the nth root of b. And then also, if we had nth root of a over b, this is nth root of a over the nth root of b. We talked about these properties in the previous sections, but in case you forgot, here they are. Example time. So let's go with simplify negative 5 cube root of 4, multiplying that by negative 4 times the cube root of 6. So please note that every term is being multiplied. So in this case, what you need to do is multiply the numbers together that is outside of the radical, so which will be negative 5 times the negative 4, and then you want to multiply that by cube root of 4 and then cube root of 6, because remember, multiplication is commutative, so which means that you can swap the orderings of your multiplication and your answer will still be the same. So for instance, this is what I'm talking about. So if I have something like 2 times 5 times maybe 3, isn't this same thing as 5 times 3 times 2? So you can swap the ordering in between multiplication, but your answer is going to be the same. So here, what we're going to get is, so first we're going to have to go negative 5 times the negative 4, which will be positive 20. And then now let's take a look at these guys. So do we have both cube root? Yes. So that means that we can take the cube root and then just multiply the radicands together. So here what we're going to get is cube root of 24. Now we can't chill just yet. So now you're going to have to ask yourself, can I still simplify cube root of 24? So let's check. So 24, 2 and a 12, 2 and a 6, 2 and a 3. So 24 is 2 to the 3rd times 3. All right, so I guess it looks like we could still simplify this. So this is same thing as 20 times the cube root of 2 to the 3rd, multiplying here by 3. So this is perfect. So what's going to happen is here you're going to have 20 times 2 times the cube root of 3. So it looks like our answer is going to be 40 times the cube root of 3. Let's do another one. We have 10 root 6p to the 3rd times 4 root 3p. Okay, so we're going to do the same thing. So we're going to swap the orderings of a multiplication here. And I'm going to rewrite this as 10 times 4. And then square root of 6p cubed. And multiplying here by the square root of 3p. Okay, so now multiplying these numbers together, what we're going to get is 40. Now, can I combine these two? Are we both given a square root? Yes, we do. So in this case, yes, we could just take the square root and then multiply the radicands together. So if I multiply the radicands together, we're going to have 6 times 3, which is 18, and then p to the third times p to the first. Remember, you add the exponents, so here you're going to have p to the fourth. So now we got to simplify. So let's go with 18. And here's 3, so 18 is 3 squared times 2. All right, and then p to the fourth. Well, p to the fourth is just fine because 2 is going to go into 4. So let me just rewrite the 18 in terms of 2 times 3 squared, and then I'm just going to leave p to the fourth. All right, so I'm going to circle the perfect ones. So here what we're going to get is 40 times by square root of 3 squared is just 3. Now the square root of p to the fourth is just p squared. Just because of this, remember, square root of p to the fourth, that's same thing as p to the 4 over 2, which is just p squared. Alright, so here I'm going to take out the p squared, and who's trapped under the radical? Poor little 2. All right, now let's simplify. So now we multiply 40 times 3, and then we're going to have p squared, and then here we're going to have square root of 2. Again, if you don't like that look, you can also rewrite it as 120 times the square root of 2 times p squared if you want, but they're all equivalent because everything's being multiplied. So here's our answer. Alright, now I'm going to ask you to try this problem on your own to see if you can get it or not. So please pause the video and try it. Now meanwhile, I'm going to start working here. So here I'm going to rewrite this as 2 times 3, fourth root of 20y squared, multiplying here by the fourth root of 28y to the third. Okay, so we're going to have 6, and then since we're both giving the fourth root, yes, we can multiply the radicands together. So here you're going to have square root of 4. 20 times 28, that will be 560. And then you're going to have y to the second times y to the third. So we add the exponents to get y to the fifth. All right, so now breakdown time. So let's go with 560. So I can think of it as 56 times 10. Now what goes into 56? 2 is going to go in. And here you're going to have 28. And then 2 times 14. 2 times 7. And then 10 is 2 times 5. Yikes. All right, so how many 2's do we have? We have 2 to the 1, 2, 3, 4. Is that right? 2 to the 4th. And then here, who's left over? 7 and a 5 is left over. So we're going to have 7 times the 5. All right, since we're looking for perfect fourth, it looks just fine now. So here, what we're going to get is 6 times the fourth root of 2 to the fourth times 7 times the 5. You can combine 7 times 5 already because they're not going to be perfect fourth. So regardless, they're going to be trapped under the fourth root anyways. And then next one for the y, so we got y to the fifth, so the break off point is y to the fourth times by y to the first. All right, now I'm going to circle the perfect ones. Okay, so what we're going to get here is 6 times fourth root of 2 to the fourth is 2. And then fourth root of y to the fourth is just going to be y. And then here you're going to have 7 times 5, which is 35, and a y. Whoops, I forgot to write down the fourth root there. So it looks like our answer is going to be 12y times the fourth root of 35y. So I'm going to box that for the final answer. How did you do on this problem? Hopefully you did it correctly, but if not, do not get bummed out. Math is all about practice. Alright, now let's take a look at something a little bit different, but we got this. Simplified cube root of 9 times the whole quantity 5 minus cube root of 18. Nothing to it, because remember the distributive property. So if you have something like a times b plus or minus c, but in this case it's minus, so I'll just keep it as minus. Distributive property says that this is going to equal to ab minus the ac. So pretend this is our a, this is b, and then this is going to be our c. So all you have to do is distribute the cube root of 9 to each term. Alright, so let's do it then. So if I distribute cube root of 9 to the first term, we're going to have 5 cube root of 9, and then minus cube root of 9 times the cube root of 18. Alright, so 9 is 3 to the second power, so it's not going to be a perfect cube. But let me check up on the 18. Oh, actually, you know what? We could multiply the radicands together first, so let's do that. So this is same thing as 5 cube root of 9, and then minus cube root of 9 times 18. What the heck is that? 162. All right. So it looks like we probably going to have to break down 162 to simplify a little bit. So let's try that. So 162, what goes in? I believe 2 is going to go in, and that's 81, 99, 33, 33. So it looks like 162 is 2 times 3 to the 4th, but we're given a cube root, so what we're looking for is perfect cube. So I should break this into 2 times 3 to the 3rd times by 3. So I'm going to rewrite it in this way. Alright, so I'm going to bring this equal sign over here. We'll just drop it down right here. Alright, so here what we're going to get is 5 times cube root of 9, which cannot be simplified, and then minus cube root of 3 to the 3rd times 2 times 3, that will be what, 6? Okay, now I'm going to do the same thing. This is the only perfect one. So here we're going to have, oops, sorry about that. We're going to have 5 cube root of 9 and then minus 3 times the cube root of 6. Okay, now let's stare at this for a little bit. Can we simplify this any further? Answer is no, because we're not given the like radicals. First radical is cube root of 9, and the second radical is cube root of 6. So you cannot do anything to this. So this is going to be our final answer. Alright, why don't you try this problem on your own by pausing the video, and we'll check our answers together when you're done. Alright, so I'm going to start off with distributing the cube root of 4 to each term. So here, what we're going to get is negative 2 cube root of 4. And then here you're going to have a minus cube root of 4 times by cube root of 6. So this gives us negative 2 cube root of 4. Cannot be simplified because 4 is 2 squared. It's not enough to make it into a perfect cube. And then here you're going to have minus, okay, we're both given the cube root here, so we can combine the radicands together. And 4 times 6 is 24. Alright, so that's what we got. Now let's see if we can simplify cube root of 24 a little bit. So I'm just going to work it on the side. 2 times 12, what is that? 2 times 6, 2 times 3, looking good. So this is 2 to the 3rd times by 3. So we do have a perfect cube there. So this is negative 2 cube root of 4 minus the cube root of 2 to the 3rd, multiplying here by 3. So this is the perfect one. So what do we get here? We get negative 2 cube root of 4 and then minus 2 times the cube root of 3. It's so tempting to combine that cube root of 4 and then cube root of 3, but they're not like radicals, so there's nothing more that you can do here. Unless you're going to get fancy and factor out the negative 2 if you want to, but you don't have to do so. So I'm just going to box that for the answer. Okay, again, let's take a look at another different kind of example. So simplify that. Okay, so we're multiplying two binomials together. So in this case, what we need to do is we need to FOIL. So let's do this. I think we can do this. So first, you're going to have to distribute the 3 to 4, and then 3 to 2 root 7, and then the inner term, and then the last term. All right, so if I do that in that order, we're going to have, don't worry, I'm going to write every step out. So here you're going to have 3 times 4, and then next one is going to be minus 3 times 2 square root of 7, and then minus 4 times 2 square root of 7, and the last one is going to be negative times the negative, so it's going to become positive 2 root 7 multiplying here by the 2 root 7. Okay, so now here what we're going to get is 12 minus 6 root 7, 8 root 7, and then here you're going to have plus. Now this is being multiplied, so again we're going to have to go 2 times 2, which is going to be 4, and then we're going to have the square root of 7 times the square root of 7. Again, I'm doing this step by step by step. So here we're going to have 12, and then we can combine minus 6 square root of 7 minus 8 square root of 7. So how many square root of 7s do we have? Well, it's the same thing as minus 6 minus 8, which is minus 14. So here you're going to have minus 14 square root of 7 plus 4, and then now let's take a look at this guy. What's square root of 7 times square root of 7? Well, that's just 7. So I'm just going to write it as 7. Okay, one more step. We got 12 minus 14 square root of 7, and then plus 28. All right, we're not done. One more step. So we're still going to have to combine 28 and a 12. So what is that? Is that 40? So it looks like we're going to have 40 minus 14 square root of 7. So I'm going to box that for the answer. Okay, let's just do another one. Again, I want to see if you can do this or not on your own, so please pause the video and try this. And meanwhile, I'm going to start working here. So I'm going to FOIL again. So it looks like what we're going to get is cube root of x times the cube root of x plus 4 times the cube root of x, and the inner term is minus 2 cube root of x, and the last term is going to be negative 2 times positive 4, so it's going to be minus 8. Okay, so now it looks like we can combine these guys together because they're both in cube roots. So we got cube root of x times x, which will give us x squared. And then we can combine these guys because we have the like radicals of cube root of x. So it looks like this is going to be 4 minus 2, which will be just plus 2, cube root of x, and then minus the 8. Okay, so now can we simplify this any further? I don't think so, because look at it. Although we're given both cube root, our radicands are different. First one is x squared, and then the second one is x. So they're not like radicals. So there's nothing else that you can do about this problem, so you stop right here and then smile, then box your final answer. All right, let's take a look at part C. Whole quantity 4 minus 2 root 5 to the second power. Now be careful, this does not equal to 4 squared minus 2 times root 5 squared. No, no, no. So this means that, remember, exponents indicates repeated multiplication. So this is telling you that you need to multiply 4 minus 2 root 5 twice. So be careful right here. Okay, so then what we're going to do is we're going to do the same thing as what we did on part A and B. We FOIL. Alright, so here you're going to have 4 times 4, which is 16. And then we're going to have minus 4 times 2 root 5. So it looks like 8 root 5. Inner term is going to be minus 4 times 2, which will be 8 square root of 5. And the last term is going to be plus because you have a negative times the negative, and it looks like here you're going to have 2 root 5 whole thing squared, because we're going to have 2 root 5 times the 2 root 5. All right, so now let's simplify this a little bit. So we're going to have 16, and then we can combine those two. It's negative 8 minus 8. So this is going to negative, is that 16 square root of 5, and then plus, now remember, let's take a look at this guy right here. Remember, if you have a b to the n, this is a to the n times the b to the n. So if we have 2 square root of 5 squared, this is 2 squared times the square root of 5 squared. Alright, in this case, this is going to be 4 times by square root of 5 squared just gives us 5. So we're going to have 20. Okay, so here I'm going to replace that by, I'll just write every step out. 2 squared times by square root of 5 squared. So we're going to have 16 minus 16 root 5, and then plus 4 times 5. All right, we got this. So this is going to be 16 minus 16 square root of 5 plus 20. Oh, you know what? One more thing. I know, it's so tempting to go 16 minus 16 first and make that into a 0, right? But no, remember the order of operations. The second 16 is stuck on square root of 5. So you cannot first subtract. You need to consider the multiplication first. But anyways, so this is same thing as 16 plus 20. So that will give us 36. And then minus 16. And then square root of 5. Okay, let's do another one. We have the whole quantity 9 minus 2 root 10 to the second power. So I want you to try this. So please pause the video and get to work. Okay, I'm going to start this problem by rewriting this as 9 minus 2 root 10, multiplying here by the 9 minus 2 root 10. And we FOIL. So the first term is going to be 9 times 9, 81. And then you're going to have 9 times, so next sign is going to be minus. 9 times 2, 18. Square root of 10. And the inner term is going to be minus 18. Square root of 10. And the last one is going to be plus 2 square root of 10 whole thing squared. Okay, so now let's take a look at 81, and I think we can combine these two. Yes, negative 18 minus 18, what is that? Negative 36 square root of 10, and then here you're going to have plus 2 squared times the square root of 10 squared. Let's keep going. So this is 81 minus 36 square root of 10, and then plus 4 times square root of 10 squared is just 10. So this is 81 minus 36 square root of 10 plus 40. Which gives us, now we can combine 81 plus 40. What is the 121? And then minus 36 square root of 10. And again, square root of 10 cannot be simplified. So let's box that for the answer. Okay, now I'm going to stop here, or I should say I'm done torturing you for the day. But anyways, if you have any questions about the material, please let me know. And once again, great job, team. You got this.